Alright, let's do this problem here. Design a data structure that is initialized with a list of different words. Provided a string, you should determine if you can change exactly one character in the string to match any word in the data structure. Implement magic dictionary class. Magic dictionary initializes the object. If you change exactly one character in the string to make that is initialized with a list of different words, provided a change determine if you can change exactly one character to. Okay. Okay. This one doesn't seem too bad. Okay, wait, is this a try? Then I'm gonna die. Okay, I have to do a try. I hate doing those types of stuff, but I guess try LeetCode boilerplate. Because I always forget how to use a boilerplate. Okay, whatever. I can maybe try to do it without a thing, but I think the time complex. Maybe it's possible. Okay. So first is probably build self.s dict or okay, we'll do this. Wait, what? We're not given the words? Okay, I guess we'll just do set here and then we'll do for every word. If word in, I guess self, oops. Self.dict, if word in dictionary, if self dot, I guess self.dict word, yeah. So yeah, that's pretty simple, I guess. Now the thing is, oh, it's like to change a word. Okay, first is, it could be directly if. Oh, you can't delete. I guess it's something like you build up a graph here, right? So like, I guess the root case is some backtracking. So like S search word here. So we have like, say for example, hello, right? False. And you have to change it. Wow, okay, that's actually interesting. So hello, actually more like, but what do you change it to? That's the thing. I don't think we really care, to be honest. Um, yeah, actually, we don't really care. Hold on, liquid boiler. I don't know if it's like a boilerplate. Let me look that up really quick. Yeah, cheat sheet. Code template. This is what I was looking for. Try. Build a try. Okay. Are you gonna load them? Brother, why do you take so long? What could be fucking possibly so taxing to load the damn code? So dumb, bro. Okay, let me do this. Cheat sheet. Leak code. Because I forgot how to do the cheat sheet for the thing. Okay, please load. Holy shit. This thing takes 5 years to load. Hello? Holy... What is taking so long? Am I like running something in the background, bro? Like, what's up with my computer? Why does it kill the server, bro? So this is it. So we have data. Okay, I got it now. I guess we can have... Yeah, I think I'm just using hash map. Self.try equals this. And then for every word in dictionary, for a character in word, self.try equals this. Or it's more like character equals this. I guess if... Okay, no. Oh, I see. I got a traversal. Root, we'll call self.try. I swear, I forgot to set up this thing. Oh yeah, so cur. Okay, so root. I'll call this cur, I guess. So we do cur here. Cur equals. Yeah, and then let me just print that tree. Let me see how this looks like right now. Okay, yeah, I think this is exactly what I want. Hold on, let me do this JSON. Oops, let's just do this. Brother. Whatever, I don't care. I think this is H. Oh, no, 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 that's not what I want. I want them to be nested. Yeah. Very word to be nested, yeah. Wait, what? I gotta do this actually. Start this and okay, now how about this? Let me see. There you go. I think that's exactly what it is. And then I think we'll do a we'll do one of these joints. How about that? Let me see. Let me see this. Oh, that's what I have to do. Okay, so if char not in is that how it is? Hello, yes, that's what I need. So this is the setup. Okay, yeah. Now okay, let me just I need to visualize this, please. No, not this one, bro. Yes, this is so yeah. And then so that tells us that we're at the end of the thing. Now that's how we've built our tree. Now search is basically a DFS, right? So I have to do, I think it was a DFS, right? Depth first search, okay. I go through it and then so yeah, I've built the tree. Now I need to traverse the tree. I've built the tree and then now I need to, yeah. Okay, so I've built the tree. Now I need to do the logic, which is, I guess we could do, what is it called? Changes. We'll call it a one, and then we'll do, right, so we'll do a, I don't know, def DFS, which takes in a character, if character I'll maybe pass in a character here. Change. If character in search word. Okay, so if character in self.try. I guess not in self.try. The base case is if changes equals I guess 1, then return out because we don't want to. That's it. No, you're done. I guess we'll do return false, right? So if the character 9, we'll give it a chance, right? We'll do DFS at the next chart. I'm gonna do, let's do I here. Nah, we'll pass in the character. We don't really care. So character, so we'll do, nah, I actually need the index because I don't know what to do from here. Let's do I. We'll do I plus 1. But we'll also change this plus 1. Oh, no, not return false. Nah, okay, if changes equal 1, return I. Okay. Okay, yeah, that's fine. So this is so if the character is not in this self.try, then I'll increment. I can move on, and then but I have this, and this is the stopping point, right? And then otherwise, DFS and return. Otherwise, DFS at I plus 1. Changes. No need to do anything else. Okay. Now we'll call DFS here. DFS here. Result is here. So result is going to give me, well, I should say, honestly, I should return this. We'll do, of course, 0 and 0. If result equals 0, that means return false because that is not. If result equals 1, return true. Okay, hold on. If its result equals 1 and I equals length of search word minus 1, right? Then return true. If it's none of these, return false. And I just realized I don't need this, right? Because if it's 1 and I equals this, then I think we're good. Okay, hold on. I just fucked up. This is not gonna do shit. Okay, hold on. I just realized something. I and letter, I guess. And I guess, tree, I guess. We'll add tree here. We'll do this, a tree self dot tree. If character not in, it's not even a character, it's more like search word at I, not in, okay, also, if I equals length of search word equals return I. Yeah, we just want to return out of there. Oh, no. Okay, I don't know what to return here, actually. Actually, I should say return, if you've made it to the end, that's good, so return true. If changes equals 1 already, actually, if it's greater than 1, not greater, yeah, if it's greater than 1, return false. If we have an exact match, I actually, I want to return a few things, actually. I want to return true and I, not I, changes, yeah. And changes. I want to return a few things. There's a reason why I want to do that. Okay, anyways, let me discard this. Okay, now we're safe to say, okay, if search, if word or letter or character is equal to search word of I, if character in tree, then we'll call DFS on I plus 1. And we'll call tree of character, so we go one level down, and oh my god, my brain's hurting. Okay, fuck this. I'm gonna do it iteratively because I just, the recursion just, I hate recursion, bro. We'll stack. Okay, what do we add here? We're going to add search word 0. Well, I will just start with the indexes. Okay, let's check the word. So we'll do search word of 0. No, not 0. Cur. I'll call this I actually. Right? I'll call this word or letter. Check if I is equal to length of search word. If we've made it to the end of we've checked all letters. Hold on, let's check changes. That, and then if I equals length of word, then return I guess we can break, to be honest. Yeah, and then check the letter. If I guess we would say cur level self.try. If letter in self.try cur level equals cur level at letter. Right, if it's not, then we'll still. Damn, where do I go if it's not then? Like, it could be the first letter. Like, where should I go if it's, you know? That's the problem. I don't know where to go if like, for example, my main issue is where do I go? Let's say there wasn't an H, right? But that could be the, like, let's say there's it's a Bella right here. And mine says hello, right? And there's no other word with H in it. But this would be, I would have to say true, because if I change this to a B, then it will be in the dictionary, and that should return true. The problem is I can only check like one level at a time. It seems like I can't move on. Let me see this again. Yeah, I can only check, like, I can't be on this level here, you know? Oh, that sucks. That's why I have to do a backtracking, because so I could move up or something, you know? I don't even if I did backtracking, I don't know, I give up. How do I do this? Brute forced. Generalized neighbors. What is this? Huh. I see this tries. What the hell is this, bro? Why are you putting in a Google Doc? Let me see, try. Python. I swear I'm kind of close here. Okay, makes a tree node is end. Okay, where builds the try. DFS. If the count is, that's exactly what I was doing. Literally. Oh my god, this is atrocious to read. Why are you doing this? Okay. solution we try. Simple try. Okay, search. Okay, else. If I is equal to length of word, then if and diff equals return true since we needed the difference of exactly one. Else return false. Res equals false. If diff equals 0 for every letter in node. Oh, okay, I see. For every letter in search word, I guess we could say okay, I see. Hold on, I actually want that recursive map because I see the vision. Give me back my recursion. Yeah, so if the characters in the thing, right, if the characters in the thing, then go to the next index and the next level, so we can do that by try of character, and then no need to change anything, so just keep changes. If it's not, then for every character in try, if character in, okay, let's do if C in, for every character in search word, if C in try, then I plus 1 less than length of word, search word, right? Then we'll try again, search word of I. No, I don't want to be super like specific here. I'm supposed to write this pretty generally. Okay, so if character in try, I have an idea. Let me do this instead. What the hell? So we can do this. How about we'll do if, let's do this. Let's restart. Let's rethink our logic real quick. So we want to do if we are at the end. Okay, so if this, right, if in I guess level, I guess we'll say that, then we have reached the end and we want to return the result of this. If changes is equal to exactly 1 and yeah, actually we just wouldn't care about that, to be honest. If I is equal to length of search word, um, actually, if we've made it to that far, that means we've incremented. Yeah, that's never. We don't even check the index because we'll know for sure we're at the end, and we'll make sure the change is equal 1. Now let's say change if changes as is greater than 1, we can just return false immediately. Okay. Now my goal is for every so for every character and next level in self.try.items. That's really nice because that's gonna help me go to the next level, right? So this is the case. If character is equal to this, then we can just skip that because, well, yeah, just skip it. It doesn't matter. If character equals, now current is basically this search word of I, right? If it's equal to character, then we can call DFS, right? If character does not equal to, we'll do something else. So we'll go to the next letter and we'll go to the next level, right? And we'll keep changes. We don't need to do that, but it's the same thing. If it doesn't, we'll just assume and we just go to some random next level, right? Then, yeah, that's it. That's basically it. Return DFS at 0 self.try at the root and 0 changes. I feel like I might get an index error, to be honest. Exactly. Let's do that. If I equals length of search word, return changes. I'll do it in a single line. If or I is equal to length of changes. Oh, not changes. Search word. Holy bole. That sucks. I'm not getting anything. I guess I can skip this, to be honest. Actually, no, I need to do this. Wait, I should return this, right? Return this. Yeah, I should return the result of this. False, 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 false. Damn it. Maybe I should do this. Frack. I should do this actually. I need to really check first. So if I is equal to length of search word, return changes equals 1 and in next level. Yeah. Like we're on the, oh, not next level, we're on the level we are on, right? So if we take this character, we'll be on this next level, but the level we're on, we want to be at this, right? And then if the change is greater than 1, there's no point of checking further. And if we don't return true here, right? if return true, right? If return true, and then if we don't at all, then we return false here, and then we'll call this, and then we should be good here. Damn, okay, that sucks. Thought this would, oh, I know why, it's because we didn't add one here. Damn, really? Okay, so let me double check why. If it doesn't equal the character, then let's assume that we can and go to the next level, and then we'll put changes +1 and we return true. If we return false, then we will have to go to the next one. Or we could say or character. Nah, that doesn't make sense. Or I'll say this, or next level, right? I +1 right? And search word of I. Oh, I know why. It's because of this. I'm stupid. We're not exploring the current level, that's why. Ah, that sucks. What is happening? Argument of type bool is not iterable. Oh, that's why we're on the Boolean, that's why. And equals true, I guess. Because we're on that. No. If level, let me do this, print level. True. Oh, that makes sense. I think it's because of this. If not in, I would say level. Yeah, in level. What? How do I prevent it from? Let's do this. I need to check the last word letter too. Damn, bro, this is taking me a minute. If changes equals 1 and that, the length of search word. figure this out. Why is this being so weird? Okay. Next level. Dude, I'm messing this up. Okay. If changes equals 1 and the level we are on. But that means I've passed it. That's why. Yeah, I passed it. So I have to do if I equals I minus 1. Yeah, we stop here. Alright. I'm getting it wrong though. I'm doing false, 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 false. Oh, I know why. Yeah, I forgot. Actually, no. Oh, wait, hold on. No. If changes equals 1 and this is there. Yeah, this is the point of the thing. But why does it return false? This return true. Dude, what am I missing here? I actually don't know why. Okay, first off, I don't like this statement. I'm gonna say, why do you, okay, first off, I don't even want to continue even looking at if I'm at the end of the word or not. If I've made it this far, that means I've at least been at least 1, or it could be 0, right? This is fine. And I have to make sure I'm checking in 1 and the level I'm on is this. And then if character equals this, just skip this one. And then we'll return probably false, right? Yeah. Finally, bro. Okay, I'm done. Anyways, I'll see you guys tomorrow.